Unit 4, Review. Two-step equations. Let's get right into it. Distributing 6x plus 15 equals, collecting like terms, 3x plus 8. We are isolating x, so let's do that. 3x plus 15 equals 8 minus 15. 3x equals minus 7 divided by 3. X equals negative 7/3. Good. Distributing minus 4x plus 8 equals 2x plus 38. We're isolating x, so that's negative 6x plus 8 equals 38. Minus 8, that's 6x equals 30. X equals negative 5. Alright, solving equations involving fractions. We need to get rid of the fractions, so the 5 and the 4, we can multiply both sides by 20. So 20 times 3/5 x plus 2 equals 20 times 1/4. So that's 20 times 3 over 5x plus 20 times 2 equals 20 divided by 4 is 5. So that is 20 divided by 5 is 4 times 3 is 12x plus 40 equals 5. I need to isolate x, so that's 12x equals negative 35. X equals negative 35 twelfths. Okay, what do we got here? 5 and a 3 in the denominator, so multiply both sides by 15. So that's 15 times 1/5 x plus 1/3 equals 15 times 2/5 times x plus 4. Notice on this side, we only multiply the 15 one time. Don't multiply it twice through that x plus 4. Okay? So that's 15 times 1/5, that is 15 divided by 5 is 3x. 15 times 1/3 is 5. 15 divided by 5 is 3 times 2 is 6, x plus 4. 3x plus 5 equals 6x plus 24. Let's isolate x, so that's 5 equals 3x plus 24. Minus 24, minus 24. That is minus 19 equals 3x. So minus 19/3 equals x. Okay? Solving equations, variable in the denominator. So we need to multiply both sides by x to get rid of that in the denominator. So that's what this looks like. Okay? So the x's cancel. We have negative 12 equals 3x. We divide by 3. That's negative 4 equals x. Here, before we multiply through by x, let's simplify this a bit. Subtract 4 from both sides. That's 24 over negative x equals 6. Multiply both sides by x. That is negative 24 equals 6x. Divide both sides by 6. That's negative 4 equals x. Here, before we multiply through by x, let's simplify. Let's subtract 1 from both sides. So that's 2x plus 7 equals negative 5 over x. multiply through by x, so that's x times 2 over x plus 7 equals x times negative 5 over x. X times 2 over x is 2, x times 7 is 7x. X times negative 5 over x is just negative 5. Let's isolate x. 7x equals negative 7. X equals negative 1. Let's simplify here. That's negative 16 over x equals negative 10 over x plus 3. We're multiplying x through both sides, so that's negative 16 equals negative 10 plus 3x. We're isolating x. That's negative 6 equals 3x. X equals negative 2. Complex fractions, solve for x. Same deal, we want to get rid of the fractions, so we want to multiply both sides by 6. So that's 6 times 4 minus x over 3 equals 6 times 3x plus 4 over 2. 6 divided by 3 is 2, so we're left with 2 times 4 minus x. 6 divided by 2 is 3, and we're left with 3x plus 4. And there you have it. We got rid of the fraction, so let's distribute. Much easier to solve. 8 minus 2x equals 9x plus 12. Let's isolate x. That's minus 4 equals 11x. X equals negative 4/11. Okay. Here we need to multiply both sides by 20. Let's get rid of that fraction. For 5 equals 20 times 2x plus 1 over 20. 20 divided by 4 is 5 times x plus 5. 20 divided by 5 is 4 times x minus 3. 20 divided by 20 is 1, so we just have 2x plus 1. Let's distribute 5x plus 25 plus 4x minus 12 equals 2x plus 1. Collect like terms. 9x plus 13 equals 2x plus 1. Let's isolate. X equals negative 12/7. Isolating equations, multiple variables. Isolate x. Same deal. Let's just do that, right? So that's y minus 2 equals x. There you have it. X is isolated. So we're using the same principles of what we learned with solving equations. So that's y plus 2 equals 2x divided by 2. What you do to one side, do to the other. So that's y plus 2 over 2 equals x. Alright, we have a fraction here, so we're going to multiply both sides by 2. So 2 times y equals 2 times x over 2 plus 6. 2y equals x plus 12. 2y minus 12 equals x. There you have it. Okay, let's clean this up a bit. Minus 2y, that's y equals 5 halves x plus 7. Multiply both sides by 2 to get rid of that fraction, so that's 2y equals 5 times x plus 7. Let's distribute 5x plus 35 minus 35 minus 35. 2y minus 35 equals 5x. Last step, that is 2 2y minus 35 over 5 equals x. Okay, we have the x in the bottom and a bunch of other variables. Multiply both sides by x, so that's x times k equals xm plus x times n over x. So that's kx equals mx plus n. This one is one of those where you have to do a bit of factoring. So we subtract mx from both sides. That's kx minus mx equals n. And we factor in x out of both and divide by k minus m. X equals n over k minus m. Oh, y equals mx plus b. So minus b, y minus b equals mx. Divide both sides by m. Y minus b over m equals x. System of equations. Solve each system of equations by substitution. Express your answer as an ordered pair. Y equals -3. That one's already nice and easy for you, so let's plug in y equals -3 to the other equation. -3 equals 7x minus 10. Let's solve for x. X equals 1. And we already know that y equals 3. Y equals -3. So your solution is 1, -3 as a pair. Okay. Here, x equals 2y minus 3, so 3 times 2y minus 3 minus 7y equals 14. Okay, let's make sure I did that right. Yep. 6y minus 9 minus 7y equals 14. Oh crap, sorry. Folks, that's minus 14, minus 14. Alright. Combine like terms, that's -y minus 9 equals -14. Let's isolate y. -5. Right? Divide by -1, that's y equals 5. And then plugging that back in, x equals 2 times 5 minus 3. X equals 10 minus 3 equals 7. So the ordered pair is 7, 5. This one, we have to do a bit of rearranging, make your life easy. Let's rearrange that one. That's x minus 2y equals -6. We can add 2y to both sides. And we get x equals 2y minus 6. So take that and plug it back into there. So that's 4 times 2y minus 6 plus 6y equals 4. That's 8y minus 24 plus 6y equals 4. That's 14y minus 24 equals 4. Let's isolate y, so we have 14y equals 28. Y equals 2. Let's take that and plug it back into one of the equations. So that's x minus 2y equals -6. We'll plug it back in there. So that's x minus 2 times 2 equals -6. X minus 4 equals -6. X equals -2. So your ordered pair is -2. And here's your y value of 2. There's your answer. Everybody's favorite, word problems. Let's do some word problems. Translate the following phrases into an algebraic expression. Use the variable x. 1/9 of a number increased by 17. So of a number, so the number is x. 1/9 of it, 1/9 times x. Increased by 7, keyword, that's add 17. Increased by 17, okay? So start with a number. So a number, 4 less than 11 times a number. 11 times a number, and 4 less than it. Quadruple the sum of 2 times a number and 8. So let's start with the number. So 2 times a number, the sum of 2 times a number and 8. So the sum of 2 times a number of 8, and quadruple the sum of 2 times a number and 8. 9 less than 8/13 of a number. So here's the number, 8/13. 9 less than that, minus 9. Word problems, various types, and this will be representative, the next few word problems. Let's see. We have this pipe, 54 inches. It's in 2 parts. What is the value of x? So we know the 2 parts, 2x plus 26 equals 54. So that's how you set up the equation. Let's isolate x. That is 2x. So messy. Let's redo that, folks. So that's 2x plus 26 equals 54, because we know these 2 parts of the pipe equals 54 inches. Minus 26, that's 2x equals, that is 14 minus 6 is 8. 4 minus 2 is 2, 28. Is that right? Yep. Divided by 2x equals 14. What is the value of x? So x equals 14. We've answered the question. Good. Lily's aquarium has 4 more than double the number of fish in John's aquarium. If f represents the number of fish in John's aquarium, write an expression that describes the number of fish in Lily's aquarium. So let f equal number fish for John. It says Lily's aquarium has 4 more than double the number of fish in John's aquarium. So for Lily, we have 4 more than double the number of fish. So double the number of fish than John and 4 more. So write an expression that describes the number of fish in Lily's aquarium. There you have it. Length of a football field is 30 yards more than its width. Let's draw this. So write a mathematical expression for the length of the field using W to represent the width. So there's the width. That's what a football field looks like. 30 yards more than the width. Here's the length. It's 30 yards more than the width. There you go. So A is length equals W plus 30. What is the length of the field if the width is 53 yards? So we are saying W equals 53. So L equals 53. So it's a substitution. L equals 83 yards. Sum of 3 consecutive integers is negative 39. Determine the integers. X plus 1 plus x plus 2 equals negative 39. 3 consecutive integers. That's 3x plus 3 equals negative 39. Let's isolate x. 3x equals negative 42. X equals negative 14. Right? Because 14 times 3 is 42. Good. So x is negative 14. Determine all the integers. So we have x equals negative 14. X plus 1 equals negative 14 plus 1 equals negative 13, and x plus 2 equals negative 14 plus 2 equals negative 12. So the three integers are negative 14, negative 13, and negative 12. Let's check that. Negative 12 plus negative 13 plus negative 14. Negative 25 plus negative 14 is negative 39. And that checks. Good. A jar contains $38.50 in toonies and quarters. A toonie is a $2 coin in Canada. There are 6 times as many quarters as toonies. Determine the number of toonies and quarters. So let x equal number of toonies. And then quarters is 6 times the number of toonies. Okay? And so what is the value of a toonie? It's $2 times the number of toonies. Remember, this is a money problem, so we have to do the value of each coin. So 2 times x. What's the value of a quarter? It's 0.25. And how many are there? There are 6x of them. And what's the total dollar value? It's $38.50. Okay? 2x plus, let's see, what's 0.25 times 6? That's 1.5. X equals 38.50. That's 3.5. X equals 38.50. X equals, what's 38.50 divided by 3.5? That's 11. X equals 11, so we said x is the number of toonies. So 11 toonies. And we said there's 6x quarters. That's 66 quarters. And let's check that to make sure that these quantities are correct. 2 times 11 is $22. 25 cents times 66 quarters. What does that equal? 0.25 times 66 is $16.50. 22 plus 16.50 is in fact $38.50. And that's your original amount. Okay? Alright folks, last page. Side 2 of a triangle is 1 meter longer than side 1. Side 3 is 1 meter longer than side 2. Alright, as we always, let x equals length of side 1. Okay, side 2 is 1 meter longer than side 1. So x plus 1 is side 2's length. And side 3 is 1 meter longer than side 2. So x plus 1 equals side 3. If the perimeter of the triangle is 33 meters, what is the length of each side? So perimeter of a triangle, remember, is side 1 plus side 2 plus side 3. The lengths of all 3 sides, okay? So x plus 1 plus x plus 2 equals 33. 3x plus 3 equals 33. X equals 10. So that's side 1. X equals 10 meters. X plus 1 equals 10 plus 1 equals 11 meters. That's side 2. And x plus 2 equals 10 plus 2 equals 12 meters. So that's side 3. Side 1, side 2, and side 3. age problem. Mina is 3 years older than Nur Aslin. Twice Nur Aslin's age minus 7 is Mina's age. How old are Mina and Nur Aslin? So let x equal age of Nur Aslin. So Mina is 3 years older than Nur Aslin. So x plus 3 equals age of Mina. Second sentence, twice Nur Aslin's age. So twice Nur Aslin's age minus 7 is Mina's age equals x plus 3. So x equals 10, and that is Mina's age equals 10. Sorry, that's Nur Aslin's age is 10. So x plus 3 equals 10 plus 3 is 13. 13, which is Mina's age. Okay, so 10 and 13. Okay, last one here, bit of interpretation. Which question could be correctly answered by solving the following equation? X minus 1 and 2/3 equals 2 and 3/4. So we have to read each and decipher which one describes that equation. Simon had 1 2/3 square meters of cloth to make a baby dress. He had 2 3/4 square meters of cloth left after he made the dress. How many square meters of cloth did Simon use to make a dress? Well, first off, this doesn't work because if he starts with this much and he cuts out a larger amount, that doesn't make sense. How could you be left with that amount, right? So we're starting with this, which is a smaller amount, cutting out this from that. So that doesn't make sense, so A doesn't work. Simon made a cardboard sign that was 1 2/3 feet long. Then he made a second sign that had a length that was 2 3/4 feet shorter than the first sign. What is the length of the second sign? That doesn't make sense because if he made a sign first that was 1 2/3 feet long, then he made a second sign that had a length that was 2 3/4 feet shorter than 1 2/3. That doesn't make sense either. You'd have a negative length sign. Okay, so that doesn't make sense. Simon has a bottle with 1 2/3 liter of water. He used 2 3/4 liters to make fruit juice. How much water was left in the bottle? Again, we're having negative quantities. If we start with this much water and we use more than what's in the bottle, then we'd have a negative quantity, and that can't be, right? And that's not what's described in this equation. So it has to be D. So let's see why. Simon had 2 3/4 cup of flour left after he used 1 2/3 cups of flour to bake a cake. How much flour did Simon have before baking the cake? So if he started with an unknown value and he used 1 2/3, it says he has 2 3/4 cups of flour left, and that one perfectly describes the equation. So letter D is correct.